So hello dear viewers, let's dive into introduction to integration. But before we dive into that, remember to subscribe this YouTube channel. Let's dive into this. Now, by definition, integration is the opposite of differentiation. What do we mean? If you differentiate x squared, you are going to get x. So if I wanted to get x squared back, I integrate this. So integration of 2x dx actually gives us x squared plus a constant. So integration is the opposite of differentiation. But let's look at some basic formulas and some integral forms that can aid us to move on with the integration techniques here. So let's say you are integrating x to the power n dx here. So this one, if you integrate it, will be x raised the power by 1 divided by the result plus a constant. So for example, say you are integrating x squared dx. In fact, you are going to get x cubed out of 3 plus a constant. Let's say you are integrating x plus 2 squared dx. We try to first expand that. So you'll use this identity plus b squared is equal to a squared plus twice them plus b squared. So we expand it. So this becomes integral of x squared, x1, this x squared plus twice them is 4x, then plus this term squared, which is 4 dx. So handling the integral of each part alone, so integral of x squared, that's x cubed out of 3, plus integrating this, keep 4, raise the power by 1, x squared out of 2. So integrating this one, we assume we are integrating a constant with x to the power 0. So how do we handle this? So this will become 4x. So it becomes plus 1, it becomes x out of 1. That leaves us with 4x. So integrating a constant dx actually gives you ax. So integrating dx alone will give you x plus a constant, So that's how we have used it here. So let's assume that you are integrating probably x plus 1 out of root x here, dx. So you first express this into indices and raise it up there. So it becomes actually integral of x plus integral of that. So integrate each part alone, x squared out of 2 plus, so add the power here, divide by the del. So if you add 1, you get a half. If you divide by a half, you get 2 root x plus a constant. So what if we had this form here, say maybe x power n dx, and we have the limits as a to b. So this is called a definite integral because we are not going to add a constant. So you are going to get an answer to this expression. So this will become raise the power by 1, divide by the result, then substitute in the limit. So if feed in b in the place of x, subtract when you feed in a. So this becomes b to the power n plus 1 out of n plus 1. Minus 8 power n plus 1 out of n plus 1. So you don't add a constant here, this gives us a value. Let's say maybe you are integrating x cubed 0 to 1 here, dx. What do we mean? So this will be x power 4 out of 4, substituting 0 to 1 here. So that gives us 1 power 4 out of 4 minus 0 to power 4 out of 4. This gives us a quarter here. Note that say maybe you are integrating this dx, and there is a negative, you have this limit. So I can kill this negative by actually inverting the limits here. So it becomes this dx. So you can work with inverting limits and swapping this sign here. Let's look at the third form. We are assuming we're integrating this to power n dx. So that becomes ax plus b to power n plus 1 out of n plus 1 times this one plus c. What do we mean? That you raise the power by 1, then divide by the result, then divide by the derivative of this bracket here. Remember, this function should be linear. So if there is x squared, it cannot work. We shall need other methods there. So let's say maybe you are integrating, say probably you're integrating 2x minus 3 to the power 4 dx here. So this will be, we raise the power by 1, so this will be 2x minus 3 to the power 5 out of 5. If we differentiate this expression, we get, differentiate 2x, you get 2 minus 0. So you get this plus c. So you divide by the derivative of the brackets there. So the final expression is this, minus 3 out of 5. Power 5, this will be 10 plus c. So in case you had something like this, integral of 2x squared minus 4 power 60. This cannot be applicable to this expression. Here we shall call in other methods as we shall see later. Let's look at this number 4, assuming you're integrating e of ax dx. Here you are going to get actually e of ax out of a plus c. So others under there, you can have ax plus b dx is equal to, write the same function out of a plus c. Let's say maybe you are integrating, say, e of epsilon here. So this gives us x plus c. Now we've explained this in details on the video called integration of exponential functions, check on the same channel here. So let's say probably you are integrating e to the power 5x dx. Actually, the simplest explanation would be that write the same function, divide by the derivative of the power. So actually, the general thing would be integrating this, dx would be write the same function, divide by the derivative of the power. As long as this function is linear. So in case this has x squared, it cannot work. You need other methods which are out of scope here. So the expanded method for this expression would be, you can use substitution or change of variable by letting u be 5x. U be this. So du dx is 5. So dx alone gives you du out of 5. So going back to this, so integral of this dx becomes integral of e to power u, then dx is du out of 5, which is this. So integrating this expression remains the same thing. So this is 1 out of 5 e of u plus c. That gives us 1 out of 5. U is 5x plus a constant c. So that is the expanded way, but this is explained deeper under integration of exponential functions. Let's say you are looking at number 5, integral of a to the power x dx. This simply becomes a to the power ax out of in a plus a constant. So maybe you are handling integral of 5 to the power x, dx becomes 5 to the power x out of in 5 plus a constant. Of course, we gave the expanded method here. So maybe we said you let 5 to the power x be some other function like this, or you can go by another method. This is one alternative there. So we look for z, so taking in on both sides. So we get us z in e. So this gives us x in 5 is equal to z. So instead of integrating this dx, I'm actually going to integrate this. So e to the power z, which is this, x in 5 dx. So integrating this, we said write the same function, then the derivative of the power, if you differentiate this, you get in 5 plus c. You can further bring this up, so this becomes e to the power in 5 to the power x out of in 5 plus c. So this leaves us with 5 to the power x out of in 5 plus c. Now under the same spirit, we can have this. So integral of, say, maybe a to the power bx, dx becomes, can be our part b, becomes a to the power bx out of b in a plus a constant. So maybe you are handling expression of 5 to the power 2x dx. This becomes 5 to the power 2x out of 2 in 5 plus c. In the same spirit, we can be handling maybe a to the power bx plus c dx. That gives us a to the power bx plus c out of b in a plus c. That means if you're integrating something like this, 2 to the power 4x minus 1 dx, that gives you 2 to the power 4x minus 1 out of 4 in 2 plus c. As long as these functions are linear, This is linear. This is also a linear function. These methods will work. Otherwise, they will not work if the functions are nonlinear. And if a is a variable like x, it cannot work here. Now let us look at number 6, assuming you're integrating something like this out of fx dx. So this becomes in fx plus c. What do we mean here? So if you say you're integrating this dx, if we're integrating something where the denominator is, if you differentiate the denominator, you get the numerator, then you take in denominator. So for example, if you differentiate x, you get 1, so this becomes in x plus a constant. So maybe you are trying to integrate something, let's say x, 2x out of 1 plus x squared dx. So if you try to differentiate this, you are going to get this. So actually this is in 1 plus x squared plus c. Now further details of this will be explained under change of variable, how you arrive at this, but these are just simple methods to help us in handling areas like integration by parts and so on and so on. So say maybe you are handling some x plus 1 out of x squared plus 2 x plus 4 dx here. So if you try to differentiate down here, so maybe dx of the denominator actually gives you 2x plus 2. So this is x plus 1. We can modify this so that can be, we can transfer this up here to x plus 1 to x plus 2, or 2 into this plus 1 out of this. But since these 2 was missing, I put half here. So the final answer will be a half in denominator plus 4 plus 6. Because if you differentiate this, you get accurately this, but because this 2 was not there, we introduced in a half here, so that gives you a half in of this. Let's look at issue 7. Say maybe you have k, derivative of this function to power n dx. This becomes k power n plus 1 out of n plus 1 plus a constant. So maybe let's take an example here. Say probably you have something like this, x squared into 2x cubed minus 4 power 5 dx here. So if our fx is this, 2x cubed minus 4, if you differentiate it, you are going to get 6x squared. So you can see x squared here, but lacks a 6 here. So we can modify these functions and say this x squared into x cubed power 5 dx becomes integral of 6x squared. We start with this, then our function power 5 dx. But since this 6 was missing here, introduce our 6th here. So I can hold our 6th here. Then this function is 2 to the power 2x cubed, raise the power by 1, that is 6, divide by 6 plus c. So that gives me 1 out of 36 into x cubed minus 4 plus a constant c. So let's look at part B. What if something was x plus 1 out of x squared plus 2x minus 4, but this is power 5 dx. So you can break this down and rearrange it into x plus 1 into x squared plus 2x minus 4 to the power negative 5 dx. So if we differentiate this, so let's fx is x squared plus 2x minus 4. So f prime x would be 2x plus 2, which is actually 2 into x plus 1. So I can express this using my function I've differentiated here. So this function here becomes, so integral of this dx now going to become this 2 into x plus 1, then times my original function here, so this x squared plus 2x minus 4 by negative 5 integral. But since there was no 2 here, so I introduce something like a half here. So this whole thing is in the correct expansion of this. So it will be now a half, handle this, x squared plus 2x minus 4. Raise the power becomes plus 1 here, becomes negative 4 out of this plus a constant. So this finally becomes negative 1 out of 8. So it becomes negative 1 out of 8 into x plus 1, 2x minus that, power 4 plus a constant. Let's look at 8 here. Integral of f prime dx here gives us fx plus c. Since integration is the opposite of differentiation, that in case I have a function here, so if the function is a derivative of something, then you call the original function. So cos is a derivative of sine, so this sine x plus c. Because when you differentiate sine, you get cos. So fx is actually sine x, then f prime is actually cos x. So let's show you what if you have x squared? Let's say maybe sine x. So it will be negative cos x. Because when you differentiate the cos, you get negative sign. Because negative is missing here, so I put it this side. So integral of x squared x dx becomes tan x plus c. Because when you differentiate the tan, you get sec squared. So integral of sec tan dx gives us actually sec x plus c. So integral of negative cosec squared x dx gives us cot x. Because when you differentiate cot, you get negative cosec squared. So in case you remove this negative, you put it on this one. So maybe you have integral of cosec cot dx. So this becomes negative cosec plus c. Let's look at trigonometrical functions. Trigonometrical functions. So you have the function, its integral. If I integrate sin x, we get negative cos x plus a constant, of course. So if I integrate cos x, I get sin x. We shall see how they come about shortly. If I integrate tan x, I'm getting that negative in cos x. If we integrate cot x, we are going to prove that. Shall get in sin x. If we integrate sec x, we shall get in sec x plus tan x. If we integrate cosec x dx, shall get in cosec x minus cot x. Of course, you can get other expression for that. So if we integrate the sin ax, dx becomes negative cos ax out of a. So if you integrated maybe cos bx, you get sin bx out of b plus c. That means that whenever you integrate a trig function, then you must give its integral divided by the derivative of the angle here. So if you differentiate ax, you get a. If you differentiate bx, you get b here. Let's look at how these things come about here. So proofs. How does sin x dx become negative cos x plus c? Here we've already explained that if you have this dx, then it's actually this plus c. This is applicable to this and also applicable to cos x dx here, which is sin x plus c. It's applicable to both of them, that in case the function under the integral is the derivative of something, then you call the function. So if you differentiate sine, you get cos. So if you differentiate negative cos, you get sine. Because if you differentiate cos alone, you get negative sine. So we took here the negative here. So let's look at tan, integral of tan x dx here. So this is A, this is B, this is C. So we express this, we are going to recall again this integral of this out of this is actually going to give us in fx plus C. So if tan is actually sine out of cos x dx, my function, the denominator is actually cos x. Its derivative is negative sine x, but there is no negative here. So this can be rearranged as negative into negative sine x out of cos x. So this is in agreement with that, so we shall have negative in cos x. If we had the cot, integral of cot becomes integral of cos x over sine x. If you differentiate this, you get this. So this becomes in sine x plus c. So let's try to look at the others. So integral of sec x dx, we modify this to be integral of sec into sec x plus tan x out of sec x plus tan x here. So we try to expand the upper things, shall get integral of sec squared x plus sec tan x out of sec x plus tan x dx. So if you differentiate this, you get this. So that gives you in sec x plus tan x plus c. So alternatively to cosec x dx, just express it to cosec into cosec x minus cot x out of cosec x minus cot x here. So this becomes cosec squared minus cosec cot, sec cot out of cosec x minus cot x here. So if you differentiate this, you get the upper thing here. So this gives us in cosec x minus cot x plus c. Let's look at some examples. Like 2 examples are enough. So assuming you're integrating sine 6x dx here. So quote the integral of sine, which is negative cos 6x, the derivative of this is 6 divided by it plus 6. Let's say you're integrating sec squared 2x dx here. So the integral of sec squared is tan 2x out of 2. Because when you differentiate tan, you get sec squared, but derivative of the angle is 2, so divide by 2. Let's say maybe you're integrating cos 2 cos 4x minus 1 dx. So keep a 2 is a constant, keep it out. You'll get this 4x minus 1 dx. So this gives us 2. Integral of cos is sine, so it is sine 4x minus 1 out of derivative of this angle is 4 plus c. So that gives you sine 4x minus 1 out of 2 plus c. Let's look at integration of even powers of sine and cos. So to integrate even powers, we mean something like this, that if you integrate sine squared dx, integrate maybe cos power 4x dx, what do? So we shall use what we call the double angle formula in cos. So note that cos 2x is actually 2 cos squared if you expand it. So making cos squared the subject, you get cos squared x is equal to 1 plus cos 2x out of 2. So we can also expand it in sine, becomes 1 minus 2 sine squared x. So if you make sine squared the subject, it becomes 1 minus cos 2x out of 2. So let's try to tackle one of these. So maybe I'm expanding sine squared 2x dx. So I go back this expression, what's the sine expression is, becomes integral of 1 minus cos twice the angle, there is a 2 here, so it becomes 4x out of 2 dx. So it becomes a half minus cos 4x out of 2 integral dx. So this becomes, integrating this will be x out of 2, minus integrating this will be sine 4x out of 2, but times the derivative of the angle, which is 4 plus c. So that gives you x out of 2 minus sine 4x out of 8 plus c. So you do the same in case you are given cos. So let's say maybe you are integrating cos squared x dx. So this will become integral. Cos squared is actually this expression that becomes 1 plus cos twice the angle out of 2 dx. So further it becomes x out of 2 plus derivative of cos is sine 2x out of 2, but there is a 2, so it comes out of 4 plus c. Now we're looking at integration of all the powers of sine and cos. We mean now if you have sine cubed x dx, you have integral of cos cubed 4x dx. What do? So you shall just keep note of this, that in case you have the integral of sine x cos power this dx becomes negative cos power n plus 1 x out of n plus 1 plus c. So what if you have cos x sine power n this dx becomes sine n plus 1 x out of n plus 1 plus a constant. Let's look at some examples here. So let's say you are integrating sine cubed x dx. Normally we first express this to cause a cos in it, so we shall have it broken down into a product of two functions like this. Then we express this term of cos, so it's sine x into 1 minus cos squared x dx. So expanding this, sine x minus sine x cos squared x dx. So integral of sine is negative cos x. So this one, since I have this expression here, so sine is here, cos is there, it's negative, so this becomes positive. Cos raised the power by 1 out of 3 plus a constant. So looking at part B, maybe integral of cos cubed 4x dx. This now becomes cos 4x times cos 4x, but this is square dx. So expanding this becomes integral of cos 4x into 1 minus sine squared 4x dx. So expanding that, that becomes cos 4x minus cos 4x sine squared 4x dx here. So integral of cos becomes sine 4x out of 4. Derivative of the angle here is 4 minus cos 4x. We dump into this, so this gives us sine to power 3 4x out of the 3, but times the derivative of the angle, which is 4. So that gives you ideally sine 4x out of 4 minus sine cubed 4x out of 12 plus a constant. So let us look at integration using the factor formula. Integration using factor formula. Recalling down the factor formula, sine A plus sine B is equal to sine A plus B out of 2 cos A minus B out of 2. Then sine the difference, sine A minus sine B becomes 2 cos A plus B out of 2 sine A minus B out of 2. Out of cos plus cos, cos A plus cos B becomes 2 cos cos, 2 cos A plus B, then cos A minus B out of 2. Then if you have cos A minus cos B, comes negative 2 sine A plus B out of 2, sine A minus B out of 2. Now let's look into examples. So maybe you are integrating cos 4x sine 6x dx. It's better to write with the bigger angle first to avoid the negatives, but you can work with negatives. Keeping in mind cos of a negative angle is a positive value, sine of a negative is a negative angle. So we can, to avoid negatives, we can maneuver with this first, so it will become So solution to this becomes sine 6x cos 4x dx. So we check sine cos. Sine cos is this. So because there is no 2 here, that means there is a 2 carried in form of a half there. So this function will become a half integral sine the sum. So it is sine add angles, so 10x. Don't divide by 2 if you are reversing. So sine subtract angles. 6 minus 4, that gives us 2x dx. So handling the math, integral of sine is negative cos. So negative cos of 10x out of 10, then minus cos 2x out of 2 plus a constant. So that gives you, can factor out these 2 again, that gives you negative a quarter into cos 10x out of 5 plus cos 2x plus constant.